Hey you guys, welcome back to the channel PHYSICSSIRJEE, and here we are in NCERT Physics in-depth doubts series, in which I have brought forward to you a question from NCERT Exemplar problem 1.11 from the chapter of electrostatics, and we'll try to see it's a more than one correct option type situation in which a wrong key has been printed in the NCERT Exemplar solution, and we'll try to correct that by going through the concept in a detailed manner. This is actually a follow-up video to the resolved 26 video on the idea of the definition of dipole moment of a system of charges. Okay, so in case you have not yet watched that particular video and you're coming here for the first time, I would request you to go back and watch it. I'll give you the link of that particular video during the solution of this particular problem. Okay, so why is it important that we go through the NCERT in a in-depth manner? Recently the JEE has added some of the more topics from NCERT to the JEE advanced syllabus, so it becomes imperative that we go through these things in a detailed manner, and also it becomes even more important that if anything wrong is published either in NCERT textbook or NCERT exemplar material, we are supposed to highlight it. Okay, so all this is done in order to ensure that our subject becomes better and we are in a better position in the examinations to attempt questions. Okay, so with all that out of our way, let's try to see the problem statement. Okay, so those who have followed the previous video, this was the statement you might have attempted, and some of them have commented the correct answer also. So just try to read this question, pause the video, attempt it again in case you're new, and then we'll go ahead with the concept and the solution. And also at the end of this video, as usual, I'll give you a few practice problems to better your understanding of this concept. Okay, right. So let me go through the formal reading. Consider a region inside which there are various types of charges, but the total charge is 0. Okay, so total charge is supposed to be 0 here. Right. And at the points outside the region, the electric field is necessarily 0 is the first option. The electric field is due to the dipole moment of the charge distribution only. The dominant electric field is proportional to 1 by distance cube for large distances from the origin in the region. And work done to move a charged particle along a closed path away from the region will be a 0. So these are the 4 options, of which one or more than one could be correct. Okay, so I hope you have given it a decent try. Let me go back and see the concept. Okay, right. Before I start off the concept and the solution and the practice problems, a humble request as always to like the video and so as to share it. YouTube algorithm recognizes better liked videos, so I'm having confidence in the quality that I'm producing. So requesting for likes, I don't think is an overt thing to do. So thanks for all the support. Those are returning subscribers who have been doing what I've requested them. So let's keep this journey going and the channel alive. Okay, so let's move on. So as I said, please watch the video, which is the definition of electric dipole moment in the resolved series, in which the sum of all charges of system is 0 or not. We actually have defined the electric dipole moment. There is a general misconception among students that dipole moment is supposed to be only for net charge equal to 0 systems, but even when it is not, we have discussed the general case. Okay, so link of that video is in the description below or the I button above. And in that we have expressed the potential at a large distance for a system of charges. Okay, so please go through it. I'll also revise what we did in that video in the next slide, but it will be quick and less elaborate than what I did in the last video. Okay, so let me move forward. So this was the slide I directly picked from that previous video. So some of you might have recognized it. So what we did there is having a system of charges and at a large distance, try to write the potential due to this system. Okay, so this system throws up upon approximations a sequence of terms for the potential at large distance. Each of these terms have a physical significance, and we left out the higher order terms at that particular video in order to discuss it in this one. So our job is to revise this and also redefine what are these higher order terms. And in these terms, one of the term, which is sigma QI was called the dipole electric moment, and becomes a dominant one or becomes the lead producer of the potential if the first term is 0, which is the summation of the charges equal to 0. And that throws up the example of dipole being one of the examples. Okay, so Only if sigma qi is 0, the second term decides the potential. And if potential for that system is 1 by r square style of potential at large distance, then the field has to be by differentiation 1 by r cube. Then we threw up an interesting question saying that what if I have a system of charges in which not only the first term, that is sum of charges, but also the dipole moment comes out to be 0. Then you can't say potential is 0, but you have to look for the higher order terms being able to produce the potential and thereby the field. And that is where the NCERT exemplar problem solution was wrong. Okay, so let me clarify. What are these higher order terms that we are looking at in this video? The higher order terms would be a situation where these two are simultaneously 0. Okay, right. I've given an example at the bottom left of your screen. You can see the dipole moment also of this system is 0. One dipole moment is this way, another. So net is 0. So at a large distance r from here, what would be the value of the field? These two terms will not be contributing. So we have to look at these terms. Okay, so once you go forward, those terms would be something like this. So the calculations are slightly tougher. Our job is to get only proportionality, so I am not calculating. So the calculation part, we will look at some practice problems for those. Okay, so idea is to realize that this term, which is the monopole term, is going to be potential wise 1 by r, and field wise therefore it should be 1 by r square. Okay, and the second term, which is the dipole term, is potential wise itself 1 by r square, and therefore the field wise would be 1 by r cube. Then the next term, which is going to be the quadrupole term, would be a slightly complicated summation. So this was a scalar. This dipole moment was a vector. The next terms will all be tensors. Okay, so don't get tensed by listening to the word tensor, because a lot of you JEE students will not have any idea of tensors. But the calculations that could be involved in a JEE exam for these tensors would be of easier type. Okay, so the examiner could choose an easier calculation to ask in the exam, just similar to the moment of inertia actually is a tensor. But our JEE level problems, the moment of inertia are taken in simpler situations where even if you understand the scalar operations for moment of inertia, it is done. Okay, so something like that we'll look at the practice problems. We'll not go into the higher level ideas of these higher order terms, but a simplistic situations. Okay, so trust me, this next term will come out to be proportional to 1 by r cube, I should say. So this should be 1 by r cube, and this would be 1 by r power 4. Okay, right. So let me write it properly. Yeah, I missed a term here. Yeah, this is cube, this is power 4, and so on and so forth. There is no limit to it. If any of these terms are 0, you'll look for the higher order terms. That brings us to our question that in general, whenever the sum of charges is 0, you cannot say the field is going to be given by dipole moment or 1 by r cube. It could be a situation where these two are 0, and then this term will decide. And the first three terms are 0, then this term will decide. I'll show you some of the simplistic situations. Now, these are the examples. Okay, field at a large distance in a particular direction. Always choose a particular direction and keep walking along that direction. At a large distance, for a dipole, it is 1 by r cube. And monopole, which is nothing but inverse square law, we have always 1 by r square in that particular direction. For a quadrupole that I already showed you an example in the previous slide, at a very large distance, the field falls off as 1 by r power 4. You can have a quadrupole moment also equal to 0. Then something like this, if you arrange the charges, you will have to go for the octupole term, that is the 1 by r power 4 in terms of potential and 1 by r power 5 in terms of the field at large distance in a particular direction. So let's therefore reread the question of the exemplar and see what would be the correct answer. So here's the question. We have gone through all the 4 options, right? And you could see I've pasted the key that is given in the NCERT exemplar. They given it as C and D. D is pretty obviously correct, right? That is work done in a closed path is 0 is a characteristic of a electrostatic and conservative field. So that is obviously right. So D is a correct answer there. No issues there, right? But the problem is with the option C. The option C, the dominant electric field is 1 by r cube, cannot be correct, because you could have a quadrupole system in which 1 by r power 4 can come. The surprising part here is they did not give B. which is perfect, right? So electric field is due to dipole moment of the charge distribution only, need not be right. It could be due to a quadruple. So he's recognizing that B is not right, but somehow they have printed C, giving rise to the misconception among students. So this is the correct key. Answer should be only D in this problem. Okay, so correct key is only D and not the C comma D. So once we are done, let's look at some examples and practice problems. So a simple quadruple field calculation could be recognized like this. So you see there is a linear electric quadruple moment. I kept it simple. Instead of the tougher one that I showed in the example, I've placed two charges in a linear manner. And the person can ask a field on the equatorial line or on the axial line. Here, for those students who are new to this concept, I have pasted the calculation how the JEE can ask what is a field on the equatorial line. So at a very large distance, it's pretty simple, basic thing. As if these are individual charges, you get the calculation of the field here, vectorially add them, and use the binomial approximation of this R being very large compared to D, you end up getting, as expected, 1 by R power 4. So here is a simple example to counter the options given in the NCERT exemplar. So for this one, in this direction, it is 1 by R power 4. In any other direction going, you will have 1 by R power 4, but the coefficient of proportionality could be different. Okay. So I'll give you a practice problem in the other direction, which is the axial direction, and you could see the calculation there. Right? So another important thing is to visualize how the field map changes from a dipole to quadrupole. So on the left side of your screen, you have a normal dipole where negative and positive charge are simply separated by a distance. Due to this, there will be a unique field map. At large distances, it will fall off as 1 by R power 4. And the right hand side, this is your quadrupole that I gave an example for. Okay. And for this quadrupole, let's try to see how the field map comparison would be. Okay. So it's very simple, something like this. So you could see the tab at the top. Let me pause it. So when the tab is on this side, and this is a dipole moment vector of the blue charge, you can say is the positive charge, and the red one is the negative charge, for suppose. And once I take this tab to the right, the polarities of these charges separate out. And by the time I reach with the tab here, it becomes that quadruple of 4 charges arranged on a vertices of a square. So the dipole moment is 0, and then the quadruple moment takes over, and the field map changes to 1 by R power 4. Okay, so let's have a small look here. It's a nice little simulation. You could see we are in the middle. This is neither completely dipole nor completely quadruple. So, but the field map is shifting, as you could see. And this is what happens in reactions in chemistry, where reagents, when they are reacting with products or reactants, they will end up having these kind of field maps, which decide the reaction mechanism with which the reaction happens. Okay, so something like this. Now you have a quadruple formation. Okay, so you could see the plus charges and minus charges. The net dipole moment of this is 0, and the map has completely changed. So calling every map as 1 by R cube is wrong in all the way. Okay, right. So that's what I wanted to prove for this right side part. So let me move forward. Another physical situation of a quadrupole, just to gain your confidence in what we are learning here, is the same thing. If these 4 charges that we looked at in the field map just now, when will we get this in a physical situation? You all remember that for a spherical charge, we can replace the entire charge for a large distance point as a point charge in the middle. This quadruple system can be also in a similar lines be adjudged for a elliptical charge distribution. If you have an elliptically distributed charge, then you can simulate it or superpose it as if it is a combination of 2 positive charges at the end and a spherical charge, which makes it a nice little candidate for being a quadruple system. Where will you get this quadruple system? You remember in nuclear physics, you will be taught, or if you are already a student of nuclear physics, you will understand that nuclear charge actually is having a prolate and oblate ellipsoidal kind of or egg-shaped distribution. So these nuclei, when they are influencing charges from outside, let's say in a K electron capture, when electron gets captured from outside, the field is not related to 1 by r square. It would be associated with this quadrupole style of movement. Okay, so there will be physical situations in your higher level physics where these higher level movements and therefore tensors are to be used. Okay, so but let's not go into tensors part. Our practice problems will relate to just how the JEE can touch upon this concept. Okay, so I hope you are excited. Let me move forward. Before I go and present to you the practice problems, these are the different ways of connecting to me and PHYSICSSIRJEE. This Discord server. There is a Telegram group where students, serious ones, discuss their doubts together, and there is a website which is www.physicsssirjee.in. Okay, and how to use that website, what is the speciality of it, how the videos are arranged in a chapter wise for manner for quick revision. I've already made a video. The video link of that particular thing is in the description below or the I button above. Please do check it in case you are new to it. Okay, this is the practice problem 1. As always, I keep saying practice this problem. If you get a answer, kindly respond it in the comments section below using the timestamp. Without timestamp, it becomes very difficult for navigating through the doubt. Okay, I can respond to it much quickly. So just like the linear quadrupole where we found in our example the field at a large distance equatorial point, now he's asking us to find it at a axial point. What is interesting to note, if you are a student of dipole, that in case of a dipole on a equatorial and axial point large distance, the field is not the same at the same distance. I think a field at an axial point would be twice of what the magnitude of the field on the equatorial. Whereas if you look at this expression and go back in the slides to the expression we got on the equatorial point, the value of the field seems to be the same, which is interesting. That means for a quadruple, the line of attack along equatorial and line of attack along axial are similar lines. That force is almost the same, which again I keep telling you is an interesting point that which would be useful in the reaction mechanisms, whether the reagent is a quadruple reagent or a dipole reagent, and depends on, if it is dipole, then the line of attack matters, whereas in quadruple system in two different directions you have the same line. So try to see how he defined the value of the quadruple. This capital Q is a quadruple movement here, and he's expecting you to get to this expression. Okay, so I hope you can try that one out. The second one is from Irido. Okay, I forgot to paste the Irido map here. This is from problem 3.10. And again, a simple situation. As you could see, there's a point charge located at the center of a ring, and ring has a minus q charge, which means immediately you could see that the dipole moment of this system is 0, right? And therefore now at a large distance x, the answer cannot be 1 by x cube. It would be higher level terms. So can you guess the power of x without solving? And please do comment from whatever concept that I have learned, made you learn from this video. Do comment what would the power be. For the entire calculation you have to integrate. I'm looking for the guessing of the power and quickening up your calculation in case this question appears in the exam, and respond it with the timestamp below so that I can comment back whether it is correct or not. The third one, again we go back to Resnick and Halliday. Pick up a question on a dipole, and this is slightly lengthier, but it will add up to your understanding of this concept. Okay, so this is more of on the mathematical side if JE is interested in that. So he talks about the expansion of those terms, that higher level terms that I talked about. We are going to actually do that calculation. In this, he stops at this term, right, where 1 by distance cube term, and then he's asking what would be the correction term, the next important term. Okay, and obviously because it's a book, he's referring to the equations. I'll put the text required for solving this problem in the next page, so you can go to the front, read those things, what are these equations and how to get this next term. Okay, so this is a very interesting and important problem which JE can touch upon in the future. So this is the text from the Resnick and Halliday book. In case you have the book, you can directly go there. In case you don't, this is the text. Think of it as a reading comprehension. You are supposed to read this and get this next term. Very, very important. Okay, so this is the picture referring to these equations, and these equations were being used in this particular problem. Okay, Interesting one. Try it out and comment your answer below along with the timestamp. Okay. So I hope you'll enjoy solving this and taking this problem understanding to the next level so that you're ready with attacking the questions in electrostatics. You want to go through more problems from electrostatics of standard and good level, always go to the subtopic playlist that I have put for electrostatics. It has been divided into 5 subtopics. Each one of them contains gem of videos that I have been producing over the last 1.5 to 2 years. So please make sure you explore them in case you are new to the channel. Okay, description below will give you the links to them. And also the Discord server has a separate electrostatics channel and has crossed 3K subscribers, serious ones, where all of the students post channelized way of putting the doubts in the channel, and the doubts get answered very quickly. And also you can get the collection of all those doubts at one place, unlike in a Telegram group where all the chapters questions come under one thread. We have a possibility of separating them out. How to use the Discord server in case you are a beginner, I made a video tutorial on that. Link of that video is in the description below or the I button above. Trust me, once you go through that and log into the Discord server, if you are an online student, it is a gold mine that you don't want to miss. Okay, apart from the NCRT series that this video is part of, there are many other series which help the students in this channel. I've written only 4. All of them are in the description below, the playlists of these. So please try to explore them. Watch 3 or 4 videos every day to catch up with 250 odd videos that I have produced, so that you can within 2 months reach to the level of the old subscribers. Okay, so please, again, I remind you to like, share and subscribe to the channel and keep it going, so that the channel runs and my motivation is also high enough to keep producing such high quality videos. Thanks for staying this long. See you in the next awesome video.